Right, I know that you do A-level maths, but there are two very important GCSE facts that you cannot forget for your A-level maths, because these two facts come up in tricky modelling questions. And if you don't know these two facts, or if you forget to use these two facts in the question, then you're going to have a horrendous time with some of these exam questions. So let's go through them. I mean, as an example, let's say you had a modelling question where you had the profit P for a company and you had two models. You had this first model and you had this second model here. And X is the cost of the item per item. So the question for 3 marks is to find the maximum profits for both of these models. Now, what you may be thinking looking at this is, oh my God, finding the maximum of these functions. Oh no, I've got to differentiate and find stationary points. And then I've got to set the dy by dx equal to 0. And then I've got to solve all this. Oh no, this is horrendous. I've got to do quotient rule. I've got to do chain rule. I've got to do trig differentiation. Well, no, it's only 3 marks. It's not going to be that mathematically difficult if you can remember these two GCSE facts. So let's start with fact 1. I've just drawn a number line. Now pick any random number on a number line, square it. Can it be negative? No, right? When you square any real value, it is always non-negative, right? So let's be really formal about this. So let x be a real number. Then therefore what this means is that x squared cannot be less than 0, okay? Fact number 2. Go to your calculator and do sine of any number you like, right? Can you get a number bigger than 1? No, you can't. Sine of anything cannot be bigger than 1, and sine of anything cannot be less than -1. And you should know this just by drawing a sine wave and a cos wave, right? Same with cos. Cos of any number you like cannot be bigger than 1, and it cannot be less than -1. So, if you have sine of a linear angle like this here, again, this must be less than or equal to 1, but greater than or equal to -1. Now, why is that? That is because this is a linear function, and linear straight line graphs can take any y value they like, right? So these y values go on from -infinity to infinity. So these angles can be any value you like. So sine is trapped between -1 and 1. And it's exactly the same for cos 2. So let's start with model 1. Again, we're trying to maximize this profit. Now let's go through each term individually and let's see how we can edit each term to make this P as big as possible. Now 70 is a constant, okay, that's fixed. You can't change that. 70 is 70. 10, can't change that, can you? 10 is a constant, it's fixed, okay? Can't change this 52 over 3 pi, that's fixed. But you can change these values here because x is a variable, x is varying, the cost varies, right? So what we need to do then is we need to look at this square number here. This is a square number, okay? It's just a number there, squared. And again, when you square numbers, they cannot be less than 0. So I've just said that this number there must be bigger than or equal to 0. So let's just think about fractions now. So to make this fraction as big as possible, because we're trying to maximize it, okay, I need the top to be as big as possible, and it is. You can't change 70 as a constant. And I need the bottom to be as small as possible, okay, because I'm trying to maximize the fraction. I mean, let's go to the calculator, right? Let's do 70 divided by 10, okay? Now let's do 70 divided by a smaller number. Do you see how the answer is getting bigger? Right, 70 divided by 8. It's getting bigger. So when the number on the bottom of this fraction gets smaller, the answer gets bigger. I need the bottom to be as small as possible. So let's make a note of that. So we need to minimize this denominator. Now, again, we can't minimize 10 because 10 is what 10 is, right? That's a constant. Again, we can't really minimize the 52 over 3 pi because it's a constant, but we can minimize this square number. What is the minimum value of this square number? It's 0. Square numbers cannot go below 0. So the min value of this square number is 0. So that means that the maximum value of this profit is going to be 70 over 10 plus 52 over 3 pi. Sorry, my handwriting's really bad. Holding my phone up and trying to write at the same time is not easy. And then times by this number, 0. Okay, we need this to be 0 to maximize the profit. So now this just disappears because that's just 0. So the maximum profit is £7. Doesn't seem like a big profit, but oh well, that's the question. Now then, let's look at model 2. Again, a very similar principle. I want to maximize this fraction, so I need the top to be as big as possible, but again, 70 is fixed, you can't do that. But I need the bottom to be as small as possible, so I need to minimize the denominator. So again, minimize this denominator. This is fixed, you can't change that 10, it's fixed. This 52 over 3 pi is fixed, we can't change that. But we can change a sine function, yes, because sine functions are waves, they're variable. So what we need, if we want to minimize all of this, we need to minimize this trig function. And what is the minimum of sine? Well, we talked about it back here. Sine of any number you like, the minimum is -1. Okay, it's -1. So the minimum value this can be is -1. And so the maximum value of this p is going to be, again, 70 over the 10, and then plus 52 over 3 pi times by the minimum value of this sine wave, which is -1. So now we get something like this. I'll just put this in the calculator. So I've gone to the calculator, plug this in, and we get a maximum profit of about 15.62. I mean, because we're using pounds, I guess I'll just use 15.62 to 2 decimal places. So that is our maximum profit. So the maximum profit in Model 2 is bigger than the maximum profit in Model 1. So hopefully my company would be following Model 2. Well, actually, no, take that back. Hopefully my company would be following something like this instead. So with a lot of these quadratic models or these trig models or functions where there are some kind of quadratics and trig functions involved, don't think you've got to do the quotient rule, the chain rule, and spend hours and hours in an exam trying to go through all the differentiation. Because actually, if it's like a 1-2 mark question, honestly, it's probably just some GCSE facts with sine, cos waves, and x squared values. So something to bear in mind.